All right, my name is Josh. My pseudonym is Bugi Mushin. For those, if you want to contact me on Facebook or if you want to know anything else about me.
Oh, that's you.
Yeah. This is my public name.
I just realized that the other day.
Yeah, this is like on a personal basis. This is me. If there are feds around, this is me.
That's your Arcane name.
Yeah, exactly. And actually, this comes from Buddhism. Bugi means no affectation, like nothing special, and Mushin means no mind, meaning that it's only the empty mind that is ready to learn.
Yes.
My title is Logic and Context. I'm really teaching about logic, but I want to give a context, being that it's the Arcane school. I kind of want to give an introduction into the thought, about how it affected thought, what thought was before, and how it all kind of fits together. Let's see if I can get this without tearing it. Alright, so in order to begin my introduction, thought, logic, philosophy really all kind of started, as most things did, with the Greeks. So what thought was before, we're going to talk about the pre-Socratics, which means philosophers that were eminent before Socrates and Plato and Aristotle. The first person who is considered by some the grandfather of philosophy is, his name is Thales. And they consider him to be really the grandfather because Thales was the first person to question Greek mythology. He was the first person to say that earthquakes aren't caused by a god in a mountain hammering on an anvil.
What time is this? Is this just early classical or something?
Yeah, it's about early classical. I don't know the century exactly.
Roman?
Like 500
No,
or something?
this is pre-Roman.
Yeah, this is probably about 500 BC maybe.
Yeah, okay.
Because I think Anaximander and Anaximenes were contemporaries of Pythagoras. And I don't know how far Pythagoras was before Socrates, but maybe about 300 to 400 BC, somewhere around there. Okay, so Thales, he was known as the first philosopher really because he was the first person to reject Greek mythology. And the story of the earthquake is really relevant because he was the first person to really say that earthquakes aren't caused by the gods, but he tried to come up with a scientific explanation for it. He said that all the continents of the earth float on water, float on the oceans, and when they hit each other and they rub, they cause earthquakes. And I don't have the details. I had them on my computer, but my computer died. But this is actually a scientifically verified theory that came about in about 1950. It's called the theory of tectonic drift.
Yeah, plate tectonics, except it doesn't float on the ocean. It floats on an ocean of
There
rock.
There you go. On an ocean of lava, but still, it floats on an ocean. And I think, that you could come up with that, 4,500 years before modern science.
Right.
Only by trying to figure out things is a pretty big deal. So Thales, he's considered a big guy. And as was common among the time of Greek philosophers, they believed that there was what was called an arc, which was the everything of the universe. Everything is composed of a single element, and the point of philosophy was to figure out what that element was. So it was very idealistic. And because of the idea of the plates floating on the ocean, Thales picked that his arc was water. And there's a story that goes along. He didn't write anything down, so we really only kind of have oral traditions. But his theory was that he came up with it while sitting watching vapor turn into water and water turn into vapor, like on a hot day, and watching moss become wet and then decomposing. So while he was witnessing that, he picked water. And the important thing of this is that I want to emphasize is that it's in flux, is that everything's in flux, that water changes things, water is always moving. And then his student was Anaximander and Anaximenes. I don't know if there's any relation, but their names just kind of sound the same. Anaximander, he said that his arc was what he called a perion. And a perion wasn't an element. It was more of like the Taoist idea that it's just a thing. It's an essence, and the essence is everything, and the universe is made out of this essence, kind of the Buddhist idea as well. Because he believed that Thales fault was that you can't pick an element to be the underlying essence of all things, because all elements have contradictions. Water can't be dry, fire can't be cold, etc. So he said the way around that was to pick a non-elemental essence. But still, it could change. It manifests in everything, and you can't really quite pin it down in a material way. And this is important, and I'll get to it later. Anaximenes picked air as his arc because he kind of made the backwards inference that Thales did. He said that when the mist solidified, it was air solidifying and turning into water, and water further solidifying, turning into land, which made continents. And so that's why he picked air as the flux, but still, everything changes. You can't quite pin it down. It's always in a constant becoming. So it's still very idealistic. Heraclitus, he picked fire because he saw that when fire burns things, it causes a change. But the important part is it's still in flux. Everything is still in flux, and they're really trying to pin down the thing that changes things. But Heraclitus, he was very eminent. He was called the Obscure, and he came up with a famous saying that I like a lot, and I'm only saying because I like it so much, that no man steps in the same river twice, which a lot of Taoists say and a lot of Buddhists, because the whole point is everything changes constantly. You're not the same person you were smoking a cigarette on the patio that you are in the room. Just because time has passed, you're a completely different person. And then Plato, we all know a little bit better. Plato taught that, also very idealistic, that our body is a cage, we're trapped here, that the real world is the world of the forms, which is the perfect, which is the perfection. We may have chairs here on earth, but in the world of the forms there is the perfect idea of chairness, which whatever it may be, we can't know because we're in a fallen state. But none of this stuff they can really prove. It's all just an idea. It's all trying to pin down that arc, that essence that is the whole universe. And then we have Aristotle. And it is said that deep down, every man is either a Platonist or an Aristotelian. They say that Plato is the embodiment of what is ideal, and Aristotle is the embodiment of what is material. Though, some people argue that Aristotle didn't completely reject idealism, but he kind of mixed the two together. But the importance, that what I really want to focus on is that when he embraced that idea of materialism is how we come up with logic. Because even though everything is constantly becoming something else, if you really want to pin something down, you have to just tell yourself this is what it is for the sake of argumentation. And a quote that I like a lot is, it's like what Proudhon said, is that the ideal is nothing but a flower from the material. So it's, if you want to accept the ideal, you have to come from something. Even if it's not perfect, you have to accept it for the sake of argumentation, maybe. I've not read a lot of Proudhon. I'm double quoting this from Bakunin. I just like that quote. I'm going to take a drink real quick.
Yeah, he's a good guy. Hell yeah.
Alright. So Aristotle, really emphasizing materialism, he incorporated this belief into categorical logic. And the importance of categorical logic, even in the name, it implies categories. You have to be able to accept that this is this, and it belongs in that category. Wood belongs in the category of wood because it has the properties of woodness. So you have to accept that it's wood, even though if it burns or decomposes, it becomes something else. For the sake of argument, at this moment, in this specific time, it is a piece of wood. And that's where we get the first three laws of logic is the law of identity. A is A. A can stand for anything, it's just an integer. Or not an integer, but
something.
Yeah, it's just like, it's a filler. So the importance of this is he's the first person to introduce the idea of no flux. If you want to argue, and I guess in some sense this is idealistic because you're saying it's the perfect thing of what you're saying it is. You know, because if you're speaking material, it's going to change, it's going to die, it's going to move on. But at this moment in this time, it is exactly what it is. There's no flux. So then we come to the second law, which is the law of the excluded middle, which means you know, it's either A or B. There's nothing else. So you're saying it's either would or it isn't. It can't be partially would and partially not would. You have to accept it for what it is. And then the law of non-contradiction, which is pretty much the same thing. One cannot say of something that it is and that it is not in the same respect at the same time. So it's accepting the faults of, you know, of the materialism. You're saying at this specific time we're analyzing this as what it is exactly, just for the sake of argument. Yeah, and that's the meaning behind categorical logic, is you're saying it belongs to this category of things or this class of things if you want to propose that it means something, or if you're going to argue for it. And what this has to do with logic and argumentation is if you're going to pick something to argue, you're going to say this is what it is. Alright, and this is where it gets kind of thick. And we're logic. Now we're just going to get into how we compose logic in argument form. What logic really is philosophy as syntax. Okay, so now we're getting out of the abstract and we're going to get to the particular. In logic, you have what is known as operators. You have the tilde, the dot, the wedge, the horseshoe, and the tribar. The tilde means a negation, so if you want to argue that something is and something isn't something, then you use the tilde. Let me see. Yeah, so let's have the meanings here. The dot is the conjunction. If you want to say that it's raining and it's beautiful outside, then you'd put like R dot B for raining and it's beautiful. If you want to say it's either interesting or it's not, you'd put interesting, wedge, not, and so on. If you guys want to, I can make some examples. If y'all want to pitch up some arguments, I can show you how it works real quick.
Okay.
Yeah.
So if you want to say like, if you want to say it's raining or it's not outside, you put R wedge in. I know you would. You put raining or not raining, with the tilde meaning not R. But
not R, which happens to be a tautology.
yeah, and I'm gonna get to that in a second. Okay, so this part's not as interesting, but let's get to the next part.
Huh. When's the time to use like those signs, like in just in any like writing, or
Well,
just specifically like in like yeah, we'll just go into that.
well, yeah, it's just like it's just philosophy of syntax. Like if you're trying to simplify what you're saying, like a lot of lawyers consider philosophy a pre-law degree. So if you're arguing something, when we get into the forms of arguments and what's considered valid and invalid, this is going to come in handy. Because like if somebody's making an argument, you want to be able to transcribe it into logical terms, because then you can identify if it's an invalid form of argumentation. And if it's invalid, then you know you have a good rebuttal. And
Right.
you can be like, look, what you're saying doesn't even logically make sense, and I'm going to tell you why.
This helps you understand why it either will or won't.
Yeah, exactly,
Yeah.
because you have valid forms of argumentation. There's like 23 valid forms of argumentation.
Okay.
And then there's some invalid ones. This is really just a simplification. Instead of having to write out the whole thing, you can just
like shorthand or
symbolize it.
something.
Exactly, yeah.
Yeah.
It's shorthand philosophy.
That's pretty cool.
Looks like a cipher.
Yeah.
Right?
It'd be cool to have a chart like that up.
Yeah, it would.
Yeah.
But yeah, this would come in handy if y'all are interested in turning this into a series or into a logic class. This would come in handy a lot more than it would seem right now.
I'm definitely interested in more of this.
Okay, so this is where it would come in handy in building and analyzing arguments. Okay, so every argument is made out of propositions with a truth value. So if you want to say like, either it's raining or it's not, the truth value hinges on whether it's raining or it's not. And that's the truth value. If you say something like close the door or is it raining outside, there's no truth value to that because you're not actually proposing anything. Right, declarative and interrogative sentences have no truth value. And so each proposition is known as a premise. And what Aristotle was known for was developing the syllogism. And the syllogism, actually for like 1,000 years, was the only really logical form of argumentation. And a syllogism only means two premises and one conclusion, which was abandoned after we reformed logic when Frege came up with preterite logic. But for a long time, this was it. This is going a lot faster than I thought it would. Alright, and this is the part where you're talking about validity and argumentation form. These are some valid argument forms. And when you're talking about validity, you don't mean valid like in the colloquial sense, like if you're saying that's invalid or this is invalid, but it has a very specific definition. And validity means that the form of which you're choosing to argue with is acceptable. So there's several forms. Modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, constructive dilemma, and simplification. And there's about 17 more forms, which I wasn't going to write out, but these are like the first 6 that you learn. And these can all mean anything. Like for example, the horseshoe. See, like this is where the yeah, exactly. This means therefore. Okay. So you're saying P therefore Q, P Q, and this is the most basic form of logic. Here, I'll come to this side. It's called modus ponens, which means that it's raining outside, therefore water is falling from the sky. It's raining outside, and this is the conclusion indicator. Water is falling from the sky. Modus tollens means, it's raining outside, therefore water is falling from the sky. Water is not falling from the sky. That should be a negative marker.
Therefore it's not raining.
Yeah, exactly. Therefore it's not raining. Hypothetical syllogism. It's raining outside, therefore the ground is wet. The ground is wet, therefore wear, slip-resistant boots or whatever. It's raining outside, therefore wear slip-resistant boots. And you can really plug in anything else you want here. These P and Q, R and S, these don't really necessarily mean anything. They're stand-in for whatever proposition you want to make. And these are just the valid argument forms. There's some more was considered invalid argument forms, which I didn't go into because I figured it might be too much information to try and give out at once.
The next series.
Yeah, exactly. Yeah. So this is just some of the very basic stuff. Dan might actually get into this more. Some of this, like the simplification, comes in handy when you're actually doing like truth tables and you're analyzing like very complex arguments.
Yeah, truth tables are handy.
I'm gonna write a whole paper like this and put it in the mumming up.
Decipher this shit.
I can totally see how, with any argument that you might have or with any conversation, how you can just like sort of be on top of it, This it's a formula.
Exactly, and that's what it is. Like a lot of times when you see lawyers in court writing stuff down, they're writing down the arguments and placing in these different letters, trying to find out if the argument is valid or not. And if it's invalid, you can come up and you can replace the argument with a different term and prove that it's invalid. And you say, look, your argument is basically this. If you take this out and replace it with that, you can see how it doesn't make any sense. And this is where it becomes really important when you're arguing, because if you can recognize somebody's form of argumentation as invalid, immediately, the debate is over. You don't even have to take it any further because there's no line of reason. And so that's where it becomes really important when you're talking about arguing. However, validity does not always mean truth, because like Dan was saying earlier, you can plug in a tautology. and you can say it's raining outside, therefore it's raining outside. And so like I can say, this is modus ponens, this is the first argument that I showed you guys. You can say, if today is Sunday, then I am God. Today is Sunday, therefore I am God. That's a valid argument. And this was the first real problem that came about with categorical logic, when they tried to refine it. And so they have the, they introduced the idea of cogency, whether the arguments are cogent together.
Is that what determines soundness?
There you go, yeah. So whether an argument is sound, whether an argument is valid, there's a difference. Valid has to do with form, soundness has to do with like the flesh of the argument. Yeah, so therefore this argument is valid, it is uncogent, therefore it's untrue. And this MP stands for modus ponens. Alright, so we're about to wrap it up. I'm just going to talk a little bit about types of arguments. There's the deductive argument where the conclusion follows necessarily from the premises. Like if I were to say, I have the anatomy of a human being, therefore I'm a human being. You know, that's pretty deductive. You can't really deny that. Inductive is like predicting weather patterns, because you can never know for sure. You're talking about something in the future that hinges on something. You know, an asteroid could come or whatever and totally screw up your predictions. And on a scale of whether it's sound or not, you can pretty much talk about it's pretty sound because the chances of a meteor coming and screwing things up is you know, pretty unlikely. So you can say it's still like 99% sound. You know, but if you're talking about something else, there's a different form of logic that I didn't study, so I don't know that much about it, but it is out there, and if you guys are interested, you can find it. So aside from that, there's the affirmative, which is modus ponens. P, therefore Q. P is true, therefore Q must be true. So you're affirming the consequent through the antecedent. There's the negative, which is modus tollens. P, therefore Q, not Q, therefore not P. And then I can explain this a little bit on the other slide, or on the other sheet of paper. Q flows both ways, and it means two things. P is a sufficient condition for Q, meaning that you can still have Q without P if you're reading it in this formula, but you cannot have P without Q. So Q is a necessary condition for P. So that's one invalid argument form, is when you read it like this. If this were to say not P, therefore not Q, that's invalid. So if you're arguing with somebody and they use an argument in that form, you could know right away. But because Q is necessary for P, you can't have P if you don't have Q. Then there's what's known as the universal argument. This is a Venn diagram. And this is explained. This means none. I know usually when you shade something in, it means this area, but in this case it means it's not there. So you're saying all S are P. So this circle represents everything that is the category or class of S. This thing represents the category or class of everything that is P. So they intersect, and it says everything that belongs to the category of S also belongs to the category of P. And so on. No S are P. Everything that belongs to the category of S is outside the influence of the category of everything that belongs to P. And then you have the particular argument. Some S are P, and in logic, some means at least one. So there's the X represents at least one thing that belongs to the category of S that also belongs to the category of P. And some P are S, same thing, but yeah, some at least one thing that belongs to the category of P belongs to the category of S. And here it is, all together. This is the most useful tool that you will ever learn in logic. And let me take a sip real quick and I'll explain it to you. This is what is called the square of opposition. And I'm not sure who invented it. I don't know. Are you familiar with it?
No, I think I'd run into it, but I wasn't sure if I would take it on. But yeah, I'm glad you brought it up.
Yeah, so I'm not sure who invented the square of opposition, but I swear to God, if you memorize this, this is all you need to know if you take a logic class.
Yeah.
So you have what are called A, E, I, and O propositions. And they're not named thusly because of the letters of the alphabet, but this is affirmative, or affirmo, and nego, which is Latin for the affirmative and the negative. These are universal propositions, exemplified here by the Venn diagram, all SRP, no SRP, because you're talking about all categories of things. Everything that is S is either a part of P, or everything that is S has nothing to do with P. You're talking about every single thing that belongs to that category. And then I and the O propositions are what are called particulars, because either some S are P or some S are not P. And it can be vice versa. Some P are S, some P are not S. But that's what's called the particulars. And here you have the contrary. And this is important because though you're saying all SRP and no SRP, those statements are directly contrary. Meaning, they're not exactly contradictory. But they're contrary to each other. There's a better explanation that I can't really remember right now. And then you talk about subalternations. And this is important because once you start analyzing classes of premises and classes of propositions, you can be able to tell that the truth flows downward. So if you have an A proposition, you can automatically assume that an I proposition is also true. Because if all F's are P, then it logically follows that some S are P. So if everything that belongs to the category of S also belongs to the category of P, then it's logically, you can logically presume that there's at least one thing of S that belongs to the category of P. But false implication flows upwards, meaning that if there's at least one thing that belongs to the category of S that also belongs to the category of P, you cannot assume that everything that belongs to the category of S belongs to the category of P, because there could only be one thing, and there could be a million other things that only belong to the category of S. And it's the same thing over here. Everything that belongs to the category of E, if no S are P, then you can equally assume that some S are not P. However, if some S are not P, that only really tells you that there's at least one thing that belongs to the category of S that does not belong to the category of P. So you can't assume that no S are P. And then, contradictory flows crosswise. This really only came in handy for me when I was taking the class, and they just kind of give you the argument forms, and they're like, identify which argument forms are subalternates of another and which ones are contradictory. That's like high-level logic. But this is really just like a teaser. Like if you find this interesting, then we can make it a longer class and we can really get into it.
It's called the square of opposition.
Mm-hmm. Square of opposition.
Square of opposition sounds like an interesting way that whoever came up with this is pretty good.
Yeah.
Yeah, that's awesome.
And this is it. This is logic in a nutshell. This is actually propositional logic. I was trying to come up with a bridge between categorical logic and propositional logic, because there's three kinds of logic, really. It goes categorical as Aristotelian, then we had propositional logic, and then we had what's known as predicate logic, which gets really complicated. And that wasn't developed until the 18th century. So this is about halfway through it. And if you guys are interested, we can extend it, and I can have a session or part 2.
Yeah.
Hell yeah.
Hell yeah, that's good. What's great about it is that it leaves room for a lot of